Hi students, in this video I'll be going through the 2016 O-Level Additional Mathematics Paper 1 question 7. Right, so let's read the question. At a given instant, a cyclist is at a crossroad O, traveling due west at a constant speed of 5 meters per second. So over here you have the first cyclist, okay? The first cyclist, he is traveling from point O and is traveling the west direction. Okay, so in this diagram, we're moving to the left at 5 meters per second. Okay, at the same instant, a second cyclist is 100 meters away from O. So the second cyclist is starting from this point. Okay, and is now traveling due north towards O. So moving upwards is according to this diagram at a constant speed of 10 meters per second. Right? So 5 meters per second means for the first cyclist, that means every 1 second is moving 5 meters further away from point O in the left direction, okay, or in the west direction. Okay, then for the second cyclist traveling towards O at 10 meters per second, that means every second you'll move 10 meters closer to O. Okay, so let's look at the second diagram. Okay, so remember for the second cyclist, the starting position is over here, and this starting position is 100 meters away from point O. Okay, so this distance is 100 meters. Okay, the position t seconds later, when the cyclist has reached point P. So after t seconds, the first cyclist reached this point P, okay? And then the second cyclist reached this point Q, is shown in figure 2. Okay, express OP and OQ in terms of t, and hence show that the distance s meters between the two cyclists at time t is given by this expression over here. Okay, so let's go back to the first cyclist. He's moving to the westward, right? Okay, in the west direction at 5 meters per second. So t seconds later, how much distance would he have moved? Okay, so basically they want us to find this distance, okay? OP in terms of t. So every 1 second he moves 5 meters. So let's say 2 seconds he will move 5 times 2. 3 seconds he will move 5 times 3. So t seconds he will move 5 times t meters. Okay, so after t seconds he will be 5t meters away from O. Okay, and this will be the expression for OP. Okay, so OP is going to be equals to 5t meters. All right. Okay, then let's look at the second cyclist. So the second cyclist is moving from, remember, starting from here. Okay, this is the start. Okay, for the second cyclist, is moving towards point Q, right? Okay. So at 10 meters per second. So same thing. After 1 second, you'll be 10 meters away. After 2 seconds, you will have moved 10 times 2. So after 3 seconds, you'll be moved, will have moved 10 times 3. So after t seconds, you will have moved 10 times t. Okay, so that means this distance over here is going to be 10t, right? Okay, so what will OQ be? Okay, so remember the starting position to O, the distance was 100 meters. Now he has moved 10t closer, so OQ is going to be 100 minus 10t, right? Right, so OQ is going to be 100 minus 10t meters. Okay, so what they want us to find is S, the distance between the two cyclists. So if you draw a straight line, okay, to join these 2 points together, then we have a right angle triangle. So this is the S that they want us to find. Okay, so since we have a right angle triangle, then obviously what we're going to use will be Pythagoras theorem, and then we should be able to show this, right? So let's go ahead and do that. So S is going to be a square root of, okay, so this is using Pythagoras theorem. Okay, so using Pythagoras theorem, okay, S is going to be equals to OP square plus OQ square. So OP square is 5t square plus 100 minus 10t square. Okay, so okay, let's expand out the inside and then we simplify, we should be able to get this. So we'll get 25t square plus the 100 square is going to be 10,000. Okay, then okay, this one just expand it using the rainbow method, okay, like this. Okay, so if not sure, always go back to the basics. So 100 times negative 10, negative 1000 t, then another negative 1000 t. So negative 2000 t. Okay, then 10 negative 10t times negative 10t will give you 100 t squared. Okay, so we'll get square root. So group the t square term together. So 125 t square minus 2000 t plus 10,000. Okay, then based on what they want us to show, they just want us to factorize out the 125. Okay, so you'll get t square minus 16t plus 80. Right, so we show this already. Right, so it's not too difficult, and we have done a similar question like this in class before. Right. Okay, so let's take a look at part B. Okay, so they want us to obtain an expression for ds dt. Okay, so I'm going to write out the expression for s again. So s is this, right? Okay, so it's 125 t square minus 16t plus 80. All right, so this is s. Okay, so if we want to put in a form suitable for differentiation, right? So square root is power half, right? Okay, square root is power half. So it's 125 t square minus 16t plus 80 to the power of half. Okay, so to differentiate this, we're going to use the chain rule. The chain rule, the power goes in front. Okay, and this whole thing, okay, will reduce the power by 1. Okay, so if half you minus 1, you get power negative half. Okay, then we're going to differentiate the inside. Okay, so the inside, we're going to differentiate this whole term, right? We'll just leave the 125 outside, and then you can just differentiate whatever is inside this bracket. So you get 2t minus 16. Right, there's no need to go and expand it out, because you expand out, you differentiate, and after that you factorize back the 125, right? You still end up with this. Okay, so this one is just 125 times this thing only. So just leave the 125 there and just differentiate inside, and you will still be able to get the same answer. Okay, so just tidy this up a bit. Okay, so this 125 times 2t minus 16 will be on top. Okay, 2t minus 16. Okay, then below you have the half. Okay, so this half is the 2 will be below. Okay, then you have this one, we'll change it to power positive half. Okay, which you will later on, it will just become a square root lah. Okay. Okay, so power half. Okay. Okay, then you notice that at the top, we can actually factorize out a 2 from this bracket. So we end up with 125 times 2 t minus 8, right? Over, okay, this one 2. Now I'll return it to the square root form. 125 t square minus 16t plus 80. Then, okay. Okay, then finally the 2 can cancel off over here. Okay, so you'll just be left with 125 t minus 8 over square root 125 t square minus 16t plus 80, right? Okay, so this will be the expression for ds dt. Okay, so just using the chain rule. Okay, but I must admit that for 2 marks, this is a bit tricky lah, okay, to differentiate, and then after that have to simplify the expression. Okay, next one, they want us to find the least distance. Okay, so remember now the distance is s, right? Least distance will also mean minimum distance, okay, between the two cyclists. So we know that at the minimum value of s, ds dt is going to be equals to 0, right? Okay, so that's what we're going to do. So at minimum s, okay, ds over dt equals to 0. So we'll equate 125 t minus 8 over square root 125 t square minus 16t plus 80 equals to 0. Okay, so whenever you have one term a over b equals 0, it's always the numerator that's 0. The denominator can't be 0, because if the denominator is 0, then this whole thing is undefined. Okay, so from here we'll go 125 t minus 8 equals to 0. So t minus 8 equals to 0, so t will be equals to 8. Okay, so for 2 marks, you don't have to prove that it's a minimum. Okay, anyway, it's actually quite obvious if you were to try to, this is dy, df dt, right? If you were to use the first derivative test, it's quite obvious. The bottom is definitely positive already. Okay, so we just need to test the top whether it's positive or negative, right? So if you start with a number smaller than 8 inside, okay, let's say 7.9, 7.9 minus 8 is going to be negative. So that means before the stationary point, which is 8, right? T equals to 8 is negative gradient. Then the stationary point is straight, right? Then if you sub a point slightly bigger than t equals to 8, 8.1, 8.1 minus 8 is 0.1 positive, right? So it's going to be positive, so it's going to be a minimum. But anyway, for a 2-mark question like this, you don't need to go and spend the time to prove that it's a minimum. Okay, so now the minimum as, we just need to sub in the t equals to 8. Okay, so we just square root. Okay, so remember, we're going to start all the way back into the original s over here. Okay, this one, right? So going to get square root 125 bracket 8 square minus 16 times 8 plus 80. Okay, okay, then you calculate the whole thing and then square root, you should be able to get the answer of 44.7 meters. Okay, so this will be the answer. Okay, so this question still not too difficult. Okay, with more practice, you will slowly gain confidence. Right, I must admit that the expressions are not easy to manipulate. Okay, but if you try more questions, you will get more confident, and then you will be able to handle such questions easily. Right.